Hello, everybody. Let's suppose we are live. Uh, Thank you very much. I was wondering if we will be able to exercise the second part because I did have some hiccups when trying to install Elixir again. Okay. All right. Let's go very quickly. Yesterday we did the introduction, the basic types list and tuples. Let's see how much we can cover in an hour, less than an hour, so you can't, so you will not get bored. Okay, pattern matching is today's starting point. Mm, I will be placing my face very near to the camera because I need to read, and then I will be doing a lot of this because the keyboard is below the laptop in this new setup. Okay, pattern matching. In this chapter, we will learn the why the symbol known as equals is called the match operator and how to use it in pattern match inside data structures, and the ping operator, which is this previously bound values. Okay, let us bring our terminal. I will put it over here, and let's put this thing on the side. Look at this, we are wasting time. Okay, we have used the equals operator a couple times to assign variables in Elixir. And we start writing code equals, okay, and then the x. But they say this is the match operator, not an assignment operator. So let's see what's going on over here. The equal is called, this symbol operator is actually called the match operator. Let's see why, okay. And they do this funny thing that when I first saw it, I was like, okay. And this is great, you know. And then they say, let's suppose 2 match x, and we got a match error, no match. Notice that it's a valid expression and it matched because both the left and right side are equal to 1. Because we saw here that x match 1 since there is no assignment. Okay, x match 1, and then we say x 1 1 match x, but 2 doesn't match x. Okay, match error. A variable can only be assigned on the left side of the this symbol. I don't want to call it equals over here. If you want to assign t, it's not defined. But here I say here they are saying it can be only assigned on the left side. So they are talking about assignment. Let's suppose it only happens once. It only happens once. Okay, well we will see that it is possible to bound the variable to another value. Pattern matching. The match operator is not only to match against simple values, but it's also useful for structuring more complex data types. And we have this beautiful expression that you can copy paste, but we are going to write. So it's a tuple, as we saw yesterday. We have the braces. It's a pixel size, and look what we have inside: some atoms. One atom, one string, and one number. Okay. And now Let's print A, and you can see that this it performs some kind of assignment, but it's actually a match of a three size tuple with another three size tuple. In here we have only one element, not a tuple by its own, and we have another value. Therefore, we can see that A was matched to this atom. Look at this. B to the world string, and C to 42, which is very convenient. You didn't perform these assignments separated, but on the same line. You probably have seen this in JavaScript and arriving as a parameters in some functions, but in here it can be appreciated right here. If the size can be matched, different size, an error will be raised. 3 elements, 2 elements, nothing happens. An error happens. Different types. Let's hang the leaves on the right side. Oh, this is a good one. We need to write it. In here we have a tuple, and in here we have a brackets list. Let's try it. A, B, and look at this. We are fighting the setup. Uh, wrong. Look at this. Look at us. Look at me. What is this thing? Okay, I need to fix this. Bear with me for this time being. And we have the match error because we are matching a tuple with a list. Can we by ourselves try the following instead of trying, experimenting? And then we print C. And it was no, there wasn't any error present. Let us finish our session, clear the screen, and come back again. Well, interestingly, we can match on a specific values. The example below assert that the left side will only match the right side when the right side is a tuple that starts with the atom OK. Now pay attention in this. Asserts that the left side, the things that we have plans to use, we only match the right side when the tuple starts with OK. It's a kind of constraint. Okay. We are tempted to copy and paste, but let's write it. Result. Okay, and 13, 13, 13. Now we have our results. I am going to copy paste this, okay? I'm not getting lazy, but the idea has now been it's in our brain. This will not match because we are expecting an OK to appear on this right side. We are saying we need to match only if there is an OK atom in the first element. The first element is in here we have an error, and we have our match error. We did this by ourselves. The list ABC 1, 2, 3. which is a song by Michael Jackson or the Jackson's Five. ABC 1 2 3, a multi. So yeah, we have 1 2 3, and you print a or request because you evaluate A and you get the result. The result. This is good. List also supports matching on its own head and tail. Head and tail. Head and tail. Look at this. Look at this. Where is this thing? We got it right. And before hitting enter, it's a good idea to say what will happen, what will we had, and what we what's the value of tail at the end of the operation, and you make your predictions, and you take note, perhaps, and then evaluate. You see, similar to HD and TL functions, we can't match an empty list with a head and a tail pattern. Remember, this is from yesterday. Okay, if you provide an empty list, it is not defined. So we can copy paste this onto this type. The head and tail format is not only used on pattern matching, but also for prepending items to a list. You know how good is this? Clear. And we got some match, not an assignment. We are saying list is matching this list, 3 element list. And now we are saying, let's put this number. And list. Flyer. And we have our big number, so you can differentiate what happened with the head and tail pattern. The head and tail format is not only used on pattern matching, prepending items. This is not pattern matching. What happened over here? It is a format, a syntax. Why is not pattern matching? Because this operator wasn't involved. You can experiment if you put list over here and the element here. And we do it very quickly. What do you think it will happen? What happened? Can you explain it? Pattern matching allows developers to easily destructure data types such as tuples and lists, as we will see in the following chapters. Okay. It is one of the foundations of recursion. Okay, pattern matching is the foundations of recursion in Elixir. Variables in Elixir can be rebound. We already saw that. And we now have number 2. It was rebound. We don't want variables to be rebound at some point. Use the ping operator. Use the ping operator. Okay, this was mentioned at the beginning. Have a 16 value rather than rewinding the value. You want the pattern match against a variable's existing value rather than rewinding the variable. So use this operator when you don't want to rewind. Where is it? Rewind, rebound, rewind. The this new value, this variable, you are saying, okay, I want the existing value. Okay, and we, where is it? This thing inside here. 7. Okay. Equal 1 match 2, and we have the error. This is the explanation. The the example they are portraying over here. We even see the exact same error message. We use the ping operator inside other pattern matches, such as tuples or lists. X equals 1, and we are using the ping operator to say, I want to match the 1. Look at this. And then you have this tuple with the existing bound variable of x. I'm not sure if you need this because we are only reading the tutorial, but have a look. X was bound to 1. In here we are matching these two lists, 3-element list, only if the list starts with 1. Let's do that. Now we copy paste this thing because there is no syntax in here. Only these brackets and this thing. Let's use this. Hopefully I don't get all right. We have this big number and we have a match error because we are saying we will only match and therefore assign this. No, we are only matching. There are no more variables in here. But the match will happen only if we have a number 1 over here and we don't have, so there was no match. And then we have y equals 2, and in this section x is still 1. In here, just as in here, we are still having 1, and we end with this tuple. But again, this will only match if this the second component or element of the tuple is 1. If you have your big number 2099, it will not match. Then you print y, and then you say we want to perform a match. Well, now I'm giving you 2, and you get an error because x was bound to the value of 1. The list example could have been written as y. So there is no match. 1 doesn't match 2. If a variable is mentioned more than once in a pattern, all references must bind to the same value. We don't need to write this. X, x, 1, 1, x, x, 1, 2. There is no matching here, and in here, yes. In some cases, you don't care about particular value in the pattern, and you use this wildcard, which is you're only caring about the head. You're dismissing the tail. You don't care. This underscore. I read somewhere about in the Scala a community that they say, I don't care. Someone referring to this symbol like that. And it works. Head, give it the head. I don't care. about the tail. Okay, but you can put another letter over here. You can type experiments because someone someone might be tempted to say, is this a function? But it is not. The variable underscore is a space. It's a variable. Look at this. It's not a wildcard. Well, it is a wildcard. It can be word like that. It can be seen like that, but they are saying that it's a variable, a special variable. You can never read from. Look at this compile error. Although pattern matching allows to build powerful construct, its usage is limited. You cannot make function calls on the left side of a match. This is invalid. Why is invalid? Because you're calling length over a list and you're trying to match three. And here is your opportunity to contribute to the Elixir programming language. They can do. Perhaps they don't want to implement this. It adds complexity, and perhaps they are thinking it doesn't feel natural matching over functions with a value. I don't know, but you can't match with functions. You can take note of these, you know, things you have to know about Elixir, a book. But it's all in here. This finishes our introduction to pattern matching. I will hope. I wish I have some way to see some chat. I close the window over here and see if people have questions. Not because I am an expert, but to boost the conversation and say, oh, okay, that's a good question. We can look the answer later. It is time for us to move. To case, con, and if. When I read this for the first time 2 years ago, 2 years ago, imagine how much time. There was this unless keyword, but it was removed in recent versions. This is the version you can choose over here and probably find it unless. Case, con, and if. In this chapter, we will learn about case, con, and if. Do you want the exercise this? Case allows to compare a value against many patterns until we find a matching one. 1, 2, 3. This clause will not match. This clause will match and bind x to the number 2. This clause will match any value. And now that I'm seeing this, I recently recommended a training course which have good programming exercises, and now I think it should be good to do those exercises using Elixir to get acquainted, even more acquainted with Elixir. But you can spend a lifetime learning and learning and learning. I need to come up with an actual project. Okay, EX. And let's do our thing. 1, 2, 3. Do. This is the syntax. Do. And we have 4. You are seeing no match. Do they have some sort of separator? No. Let us stop here. Case is the syntax allows to compare a value, this value, against many patterns. We already saw some patterns in our previous lesson. So look at this case, 1, 2, 3. And the first pattern we are trying to match is 4, 5, 6. Do you think it will match? No. Why? Because these are different. No match. You can get this whole story, copy and paste. And then I come here and say 1. Where is my 1? Match. This will match. And we put some dots over here instead of this. Match. Okay. Because as we saw in the previous lesson, we are saying 1 will match 1. If you have some 2099 over here, it will not match. You can see this as something fixed that you say you name something and say this has to be present in order for the match to happen, and then we can bind this the x variable. Here's another one, 3. That's why it will match. And then you have the special variable. They didn't put in a name. We say you don't care. These cows will match any value because you don't care what's going on. But this was already present prior to this pattern, so it says until we find a matching one. It already finds this, so this will not happen. If here you have 2099, then this will happen. Full match, and then end. Let us see. Case pattern, sorry, case value, do, and the patterns, the list of patterns, and the end keyword. And it says the X is unused. If you want, it is a warning for, if you don't want to use it, just put some underscore. Look at this. Well, we meant to say this. Match, which is here. Match. If you want to pattern match again an existing variable, you need to use the pin operator. Case 10, any value, do, and you're using the pin operator, which is retrieving the 1. Therefore, will not match. Why? Because you're saying 10 match 1. No. And then you say underscore, I don't care. Will match. We have our result. So the main story in here is you can use the pin operator to match for existing values. Clauses also allow extra conditions to be specified via words. We are going to write this. Okay, clear. EX. Clauses also allow extra conditions to be specified via words. Remember, you have your case, your do, your end, your value, your patterns, and now we have something new. Words. we will match this pattern with this value only when x is greater than 0. Okay, I'm going to write this because I am exercising this for me, and I decided to share it with you, but I need to internalize that thing in case I see more code later in my journey that somehow I shouldn't suspend 2 years ago, but I don't know what was happening with me, what I was thinking. It doesn't matter. Now here we are again on x3. When x greater, oh my God, 0, and we have our arrow, and say will match. You can place another value. Look at this. That will be your result. And here we are using the strings. You can put booleans, but we need to. It should be the same type, but you can use. You can experiment. We will test our hypothesis, and then we have this underscore and say will match if our condition were not satisfied. Quartz on not satisfied. Will match, and we are returning a string. Okay, now let me. I am saying that both results, all the results for all the patterns should be of the same type. For example, strings, string, string, string. But you can be surprised by some peculiarities of the programming languages like JavaScript, which I happen to also like, but I haven't practiced JavaScript, but I will do it. Where is this thing? One. Let me clear this because we don't have. Actually, they are not using the pin operator, so it was okay. Case 1, 2, 3, 2, 1, 2, 3, 4, and we use tab. No, because functions are presented to us, which is great. 1, 2, 3, 4. X3. But let us use another value so the match will not happen. So let's use 2099. When x greater than 0, look at this. We have this word and it's fulfilled because x is greater than 0, but we have this thing. Perhaps we should test for that. Well, here we're going to return a string, return no match, and special. Everybody is special, and then in here we are going to return true. Two different types: string, boolean or bool, and see what will happen. True. You see, it is always good to test your predictions, your hypotheses, because we are finding that Elixir says that okay, you're returning a string and you're returning a boolean, and giving you the match whatever you want to return over here. So take another thing for the book for your notes, which is great, you know. The first class above will only match when x is positive. Keep in mind errors in Word do not leak, but simply make the Word file. HD1. Argument error. Why? Because this is not a list. The head of a number, argument error. But in here, case 1 do x. We are, okay, this is great. You are only evaluating this value for the patterns of the present over here, but x will not be assigned because you are getting an error here, an argument error, but the error will not be present. Errors in words do not leak. They only make the word fail. There was an argument error in here, but you don't know what happened. If none of the clauses match, an error is raised. Case clause and error, no case clause matching, okay. This is great because the system, Elixir system, is helping you to, you know, to see, okay, you're missing something here. For the kernel module list, words, sidebar, you're given this link. You are being given this link, which you can read when you are on when you are commuting. I mean, not driving. Then we have if. We don't want to do this. Maybe it's okay. It says that it can give you more expressiveness than the case. So it is a useful alternative. If true, do. Again, the syntax is if, the condition, and this do should be present, and the end. This works. If false, this will never be seen. Okay, so memorize this syntax. If true, do 1, 2, 3, 4. Works, and if the condition given to if returns false or nil, the body given between do and n is not executed. Instead, returns nil. If you get false, you saw this with the truthy and falsy values. Remember? Which someone tested you today about those truthy and falsy values. Perhaps you have forgotten those, unless you took notes. Because I suppose it's related to the need of memorizing things these days. If also supports else blocks, if else end. Nothing new here. If else end, you know this. And then if any variable is declared, this is about the scoping. I'll change it inside each case. On similar constructs, the declaration change will only be visible inside the construct. The result is this 2, but when you are outside, again in the outer scope over here, this field over here, think of so in geometry, here's a region. I don't know too much about geometry, but it is a good thing to say. Here is a region. Suppose you have some lines over here. Look at this. You have one region, and then you draw another region, and you are in the outer scope. Look at this. In said cases, if you want to change a value, you must return the value from the if. Notice here it seems weird because oh, we need to pay attention to this. I'm saying, well, we have an else and they are returning the x over here. What's going on? If the true was fulfilled, it should be in here. But guess what? The little friend is assigned or matched over here, and now you're seeing the x in the outer scope. Okay, let's put this uh, into practice. X match 1, and then X match if true, do 1, 2, 3, 4 X plus 2099, and we probably needed more spaces, else X by itself. And look at this, we have kind of formatting in a weird fashion. Let me do that again because I like to adhere to how people write in their programming languages. If true, do 1, 2, 3, 4 x plus 1, and in here they don't have any space. 1, 2, 3, 4, and the end, and we have the result. Okay, so if you want to see the value that you changed, or then since this is kind of the new value that you are obtaining with this expression, because you are not mutating anything in here, but you are having this new expression. If you want to see this in the outer scope, you assign it or match it. I'm just repeating what the thing says, what the this document says. I'm not giving you anything new. What I want to is to probably invite you, if you already know a programming language, just come here and read the thing. Probably you know all of this. An interesting note regarding if is that it's implemented as a macro. If it's not a special language construct, and you can see the documentation and its source for more information. If you find yourself using several if, using count. You need to use count. Consider using count. And now we have count. Count, find a matching clauses for many patterns. We have used if to check for a single condition. If you need to check across several conditions, find first one that does not evaluate to nil or false, and find the first one that does not evaluate to nil or false. Condition do okay, this is a reserved keyword, and you have several conditions. This is one, this is another, and this is another. And it says find the first one that does not evaluate to nil or false. 2 plus 2 is 4 equals 5. This is false. But you want the first one that is not false. This will not be true. Because you can rephrase this in your brain and say you want the first true expression. The first true expression. This is false, false, true. Count helps you to find the first true. Alright. This is equivalent to an else if, which we didn't see over here. Do you think else if exists? Oh, we are running out of time. Which is okay. Okay. Summing up. Can't do nil false to be true. Okay, we only have nil and false. Nil and false are the only falsy values for the count expression. And then you have the head of this list is considered true. Okay, so this is not a Boolean expression. You see, but I'm not trashing Elixir. I like Elixir. That's why I'm redoing this thing again. But semantically, you will want to see Boolean expressions. But it's okay. If all conditions returns nil or false, count clause error is raised. For this reason, it might be necessary to add a final condition equal to true. Look at this to avoid this error. Okay. Summing up, you find case, if, and count. I don't know what functions. Let's see how much time we have. 8 minutes. Variables functions. Variables functions to store and pass executable code around first class functions, they say in other languages. Okay, this is about anonymous functions, but this is very important. How did you identify functions and how did you obtain documentation for those functions? So we will read this and leave defining anonymous functions for tomorrow. Okay, we are finishing here. Functions in Elixir are identified by both their name and their arity. The arity of a function describes the number of arguments that the function takes. So trunc is the name, one is the arity, which is saying that you will only need to pass one argument to trunc, okay, and you identify it. And it's different than trunc2 because this is named. It has the same name, trunc, but it accepts 2 arguments, and it doesn't exist. We use this syntax to access documentation. It defines the h function, which you can use to access documentation for any function. And here it is, h trunc/1, the trunc number. Let's do it. H trunc. Okay. Look how beautiful this looks in color, trunk number integer. It's a loading word test we saw about the tests. And there are some examples, trunk 5.4 and gives you this. Now we can use the up arrow. I didn't know how that already pasted. How it works. Okay. Wow, that's weird. Let's see. H. Um, upcase, yeah. Uh, and it says, upcase. We didn't give any any argument arity. So remember, this thing was helping us, but we should provide the arity. Here we have another example. Downcase accepts two arguments, capitalize two arguments. Mm, True works because it's defined in the kernel. All functions in the kernel are automatically imported. You can use a module plus function to look up for anything, including operators. For example, this one. Sweet wearing I forgot. You know what? Let's do another session to see this. Let's finish this. Let's finish this session. But if I want to comment on these clauses and words, it will take us 2 hours and people will get bored. So I will use part 3. But tonight, I mean, just 10 minutes break and come up with anonymous functions. And then tomorrow we'll be seeing binary strings and char lists, keyword lists and maps, modules and functions, recursion. Probably need to speed up the thing, but I want to take my time for the anonymous functions because this will be pervasive, I suppose, in the code. There are topics in which we will be able to, even omit them. I'm not reading all this thing, by the way. Only just like over here. Very quickly, very quickly. This is too much. I'm not spending my. I will do it on my own, but not on live. On live will be only some of this. For the time being, thank you very much and see you in 10 minutes. Bye.